My name is Brittany Alexander, and I'm a senior math major at Texas Tech University, and my project was a Bayesian model for the prediction of United States presidential elections. My model used poll data and Bayesian statistics to predict American presidential elections. My model used poll data as the prior, which makes it unique because most other Bayesian models typically use either fundamental models based on economic data, or they use past election results as the prior. My model was used to predict the 2016 election on November 5th, 2016, and then after the election, the model was applied to data from 2008 and 2012. The project also had a blog about my research and the role of statistics in the 2016 election. My model used a Gaussian conjugate prior with poll data taken from Huffington Post pollster. Priors were chosen based on the political stance of a state, whether it was a red, blue, or swing state, and the demographics of that state. I had 5 different categories that each had a different prior. If it was a red or a blue state, it used another state, and if it was swing states used national polls. And then I have a list of the 5 different categories. The swing states varied a little bit from election to election, but they typically were one of the 11 states listed. And I consider states a swing state if I thought that the race was competitive enough for both parties to have a reasonable chance of winning. Only polls conducted after July 1st of the election year being predicted were included in the analysis. Here I have a table comparing the accuracy of models of predicting the winners of all 50 states plus Washington, D.C., since Washington, D.C. is included in the Electoral College. All of these models perform about the same at predicting the winner, with some slight variation. My model performed the worst in 2016 because it incorrectly predicted Ohio, likely due to the fact that my model did not adjust for trends over time and therefore did not account for the upward trend in Donald Trump's support towards the end of the election. Here I have a table comparing the root mean square error of my model, the Real Clear Politics average, and the 538 polls plus model. I looked at both the performance overall and the performance in swing states. I also compared the root mean square error including all candidates and the root mean square error just comparing the 2 major candidates. As you can see, my model was slightly more accurate than the 538 polls plus model at predicting the result for just the 2 major candidates. In swing states, my model was more accurate compared to the Real Clear Politics average, but was slightly less accurate compared to the 538 polls plus model in swing states. I think this is the most important measurement of the success of a model because it looks at the accuracy of a model of predicting the actual election result and the margin between the 2 major candidates. My model did not adjust for polling bias or trends over time, and those changes would likely improve the success of the model. The 538 polls plus model does adjust for polling bias and also accounts for trends and changes over time. My model did not perform well in swing states compared to the 538 model, but it shows promise in predicting partisan states, which are states that are consistently vote for either the Republican or Democratic candidate. If a model were to be created that took the same method in partisan states, but altered the swing states method to use fundamental models as the prior, that model could be even more accurate than this model. A paper on this project was awarded an honorable mention in the spring 2017 undergraduate statistics research competition, and a full paper on this project can be viewed at the link. I have also provided a short link to the blog on this project. I would like to thank the Texas Tech University Undergraduate Research Scholar Program, which is supported by the C.H. and Helen Jones Foundation.